Welcome to the Introduction to Econometrics course. Today we are going to discuss about the course outline. What are the things that we are going to discuss in this course? There are around 9 modules that we are going to discuss in this course, and I will let you know module by module what is there in each and every module to discuss. Now, our discussion in module 1 starts with an introduction to econometrics and econometric analysis. Here, I will let you know what is basically econometrics and what does an econometric analysis mean and what are the different steps that is involved in this econometric analysis. Econometrics is basically an application of mathematical and statistical tools with an objective to measure the empirical validity of economic theory, that is the definition of econometrics. And there are several econometricians who say that econometric analysis is just like a scientific analysis. So, that means here also, like any other science disciplines, we observe certain phenomena, we observe behavior of individuals in our society, and those your analysis unit of analysis could be individuals or firms or cities or states of or even a country, right. So, we will first hypothesize some kind of relationship, then we will try to formulate an mathematical model, then we will try to estimate the relationship, and then we will go for forecasting or policy making. These are different steps involved in an econometric analysis, and we will discuss in detail about each and every steps, that is in module 1, right. Now, in module 2, what we are going to discuss is introduction to two variable classical linear regression model. Now, at the heart of any econometric analysis, there is regression. Regression is the technique, is the single most important technique available in the entire econometric literature, through which we are actually going to estimate the economic relationship. That is why in module 2, I will let you know what exactly is regression, what is the difference between regression and correlation, another related but different concept, and then what is the original meaning of the word regression, what is the meaning in today's world about the word regression, and then I will let you know the statistical procedure that we follow in estimating a regression analysis. We will be also discussing several assumptions before we actually estimate the model. Those assumptions actually describe an idealistic world based on which, if you estimate your model applying regression, then your coefficients, the regression coefficients will give you the maximum, will give you certain desirable properties. What are the desirable properties? That also we will discuss in module 2, and we will be applying the ordinary least square technique to estimate the relationship in two variable classical linear regression model. So, OLS is the technique that we are going to learn here, and after estimating the model, we are also going to learn 3 important properties of our estimates. Okay? 3 important properties of our estimate, and those 3 properties are unbiasedness, efficiency and consistency. This is there in module 2. Then in module 3, we would be discussing hypothesis testing, and we will be discussing first of all what is the need of hypothesis testing in econometric analysis. So, in econometrics generally what we do, the ultimate objective of any econometric analysis is to draw inference about population with the help of a sample, right. For example, let us say that we are going to infer something about the consumption behavior of the population for entire Tamil Nadu, right. For that purpose, we will not be collecting data for whoever is living in Tamil Nadu, because collecting data for each and every individual from Tamil Nadu is a time consuming and huge task. Rather what we do, we will collect a random representative sample from the entire population, and then we will estimate the regression function from the sample only, and at the end of the day we will be getting sample statistic which is basically the sample counterpart of the population parameter, and this sample statistic will help you making inference about the population parameter. And since from the population you can draw a sample in n number of ways, what we need to know whether the result what we get out of one sample, is it valid for each and every sample that we collect from the population. So, that means we have to rule out the possibility of a chance factor that may lead to a particular result that you observe from a particular sample. Okay? For example, suppose you are interested in consumption behavior and thinking income is a significant factor impacting consumption, and from that particular sample the estimated equation that we are going to estimate using regression, it may so happen that that particular equation shows a significant impact of income on consumption, but there is no guarantee that if we collect another sample or n minus 1 number of other samples from the same population, in each and every population you will be getting the similar type of significant impact of income on consumption. So, that means in the process we have to rule out the chance factor. So, we have to establish the statistical significance of income on consumption, and that is where the hypothesis testing becomes important and hypothesis testing enters into the picture. So, we will be discussing different types of hypothesis, null hypothesis versus alternative hypothesis, then different concepts that are very important like test statistic, critical region, confidence interval. These are the three important concepts that we must learn to know the procedure of hypothesis testing, and that we are going to discuss in module 3. Then in module 4, what we discuss is basically the goodness of fit measure. So, why goodness of fit measure? Because here we collect a sample and we are going to estimate a regression line. So, a regression line is basically, if we, for an example, let us say that this is our, in the x axis we are measuring income, which is our independent variable, here it is consumption, and let us say that this is the regression line that you have estimated, which is yi hat equals to alpha hat plus beta hat xi. Let us say this is the line you have estimated, and your original equation was yi equals to alpha plus beta xi plus ui, okay, where y is basically consumption and x is your income, right. X is your income, this is the original function and this is the function you have estimated. Now, this regression line, when you collect a estimate regression line, that basically represent the data, the scatter plot, right. So, that means you are trying to represent the raw data with the help of this regression line, and in that sense I can tell you this line what you are fitting is basically you are trying to fit a line to represent the data what you have in your hand. So, then the question that comes to our mind, how good is this line to represent the data that you have collected? How good is this line to represent the sample that you have collected? So, that means after estimating the regression line, regression function or sample regression function, we must know what is the goodness of fit. That means how good is this line to represent your data, okay, to represent your data. That is where the goodness of fit, a measure which is known by R square, capital R square, that is called goodness of fit measure, and that is what we are going to learn in this module. So, goodness of fit measure, and then there are three related concept. One is called total sum of square, explained sum of square, and the residual sum of square. So, that means as in econometric analysis, for basically the objective of the regression analysis is to explain the total variation in your dependent variable with the help of the explanatory variable that you have collected. So, in this example basically what you are going to do here, the consumption is basically is your dependent variable and income is the independent or explanatory variable. So, this R square is going to tell you what is the percentage of total variation in consumption that you are going to explain with income, right. So, that is what we are going to learn in this particular module. So, that means if you are here what we are doing, so if your y is the dependent variable and x is the independent variable, then with the regression line our objective here is to explain the variation in y with the help of x, and that is what in that context I would be explaining out of that total variation in y how much my model is able to explain, that is given by explained sum of square, and the residual if any that is given by residual sum of square. So, that means the total variation in yi would be then explained by, can be decomposed as a sum of explained sum of square and residual sum of square. So, TSS is actually equals to ESS by RSS plus RSS, and then we will also learn about the ANOVA, analysis of variance. So, that means what are the different components and what is their contribution, and we will be deriving several other concepts from this ANOVA table. So, that is what we are going to learn in module 4. Then in module 5, what we will do, we will extend our 2 variable classical linear regression model into multiple linear regression model. The example what we are talking about, that is income and consumption, that is called a 2 variable linear regression model. Why this is called 2 variable? Because you have one independent variable, one dependent variable, that is why it is called 2 variable classical linear regression model. Then we extend this into a multiple linear regression model, and in that multiple linear regression model, first of all what we learn is what is the need and significance of a multiple linear regression model. Generally we think if we have data on multiple variable, then we can easily run a multiple linear regression model. That is all right, but first of all we need to learn what is the objective and significance of a multiple linear regression model, and we would be learning the importance of multiple linear regression model in the context of omitted variable bias. So, that means there might be several other factors apart from income that might also have some impact on consumption. If we do not include, then your model may suffer from a omitted variable bias. What is the omitted variable bias? How to measure the extent and amount of omitted variable bias, those things also we will be learning in the context of multiple linear regression model. Then we will learn the estimation and interpretation of the coefficient, because interpretation of the coefficient in a multiple linear regression model, for example, when you talk about the model yi equals to alpha plus beta xi plus ui, this is called a 2 variable classical linear regression model. And the interpretation of beta hat here in this 2 variable model, and when you write a model like this, yi equals to alpha plus beta 1 x1 I plus beta 2 x2i plus beta k xki plus ui. The interpretation of beta 1 here is actually different from the interpretation of beta 1 here in the context of two variable linear regression model. So, we will learn what is the difference in the interpretation of beta hat in the context of multiple linear regression model compared to the two variable linear regression model, right. And then we will be learning another concept called adjusted R square in this context. So, that means if you increase the number of explanatory variable in your model, it may so happen that the explanatory power of your model or R square will increase. But that does not mean that we will be entering into a game of maximizing R square. So, that means we cannot really compare the R square of two different models when your number of explanatory variables are different. So, in a two variable model and three variable model, R square is not comparable, right, because higher the number of explanatory variable, obviously higher would be the R square. So, we need to derive a different but related concept that will help us comparing the goodness of fit measure across different models with different number of explanatory variable, and there the adjusted R square enters into the picture. We will learn what is the definition meaning of adjusted R square, what is the relationship between R square and adjusted R square in the context of multiple linear regression model. Then in module 6, once again we will bring hypothesis testing. So, the hypothesis testing that we applied in a two variable linear regression model, that is basically to test the individual significance of the variable. Here, apart from testing the individual significance of the variable, what we also learn is overall significance of the model. So, that means when you have several variables in the model, how to test the overall significance of the model using the F statistic that we will learn here in module 6. Then we will learn also a fantastic relationship between the F statistic and R square, and that particular relationship will help us understand even the significance of R square also. For example, in a model, when you estimate, let us say that you have estimated a model and your R square, this is a consumption function you have estimated, and your R square turns out to be 0.15. So, that means out of the total variation in y, your model is able to explain only 15%. Now, if somebody asks you, is it a good measure or a bad measure? So, always you have to keep in mind that this value is giving you only a mathematical value. That means by one value we do not really know whether 15% that you are going to explain is a sufficient amount or not. So, that means we need to know whether this is a statistically significant value. And that particular relationship between F and R square will not only help us understanding or estimating overall significance of the model, but also we will know whether a particular value of R square is statistically significant or not. So, that is what we are going to learn here after deriving the important relationship between F and R square. Then we will also learn about the equality of two regression coefficients and testing validity of linear restrictions, then structural break-in time series analysis using Chow test. For in this particular case, basically by testing linear restriction, it may so happen that you are interested in whether x1 and x2 both having same impact on yi or not. So, that means your null hypothesis you may test whether beta 1 equals to beta 2 or not, right. This is called testing the equality of two regression coefficients, right. This is something which you can test. You can also test this type of hypothesis. Let us say I am testing this hypothesis beta 1 plus beta 2 equals to 1. So, this is called testing linear restrictions, okay, linear restriction.